All right, we've just seen that it's very easy to work with JSON in our JavaScript applications. So this time we'll take a look at working with buffer data. All right, um, binary data, we know zeros and ones, right? And that's what the computer understands. So sometimes working with binary data is useful when we're working with our web applications. And situations where that might be is when we want to transfer a compressed file, i.e. a zip file or whatever. We want to generate some dynamic images straight from the bits, or we want to send serialized binary data to make our application send this data faster. All right. So again, Node comes up with some modules for us to work with that type of data. And if you don't know what buffered data is made up of a series of octets that we have in big endian or little endian format, which means the directions that the zeros and ones are written from. All right, and the benefit of that is that it takes up a lot less space than text data. All right, and to work with buffered data, we have what we call the buffer module. And what the buffer module allows us to do is create, read, write, and manipulate binary data in a buffer structure. So it gives us a structure or an object that allows us to work with that type of data. All right. The buffer module is what we call global, so we don't need to require this function to access it. In the next video, we'll see an example of when we need to require a module in order to work with it. All right. So buffer data is going to be stored in a structure similar to an array, so it should be something you're familiar with, but they don't store it in the heap or the V8 heap, which is Google's V8 engine, which we use to execute our JavaScript. But it doesn't um, get stored in that heap. It gets stored outside the heap in what we call raw memory allocations. And because of this, we can't actually resize a buffer. So that's a drawback of it. All right. So we can do some things with buffers like converting them to strings, and but you have to be careful when you convert them to strings because you have to specify the encoding that you'll use: UTF-8, UTF-16, base64, hex, etc., etc. All right. So let's take a look at how we would actually create and read a buffer. And then in the sample code, you'll see some examples of some different ways of working with buffers. All right. So in this example, we create a new buffer that is capable of storing 256 bits. All right. All right. Then we can fill all 256 bits with 0. So we call dot fill and give it a 0. So that will fill all 256 with zeros. All right. Then we're going to write to the buffer right here. And we're going to add some text. All right. So that's going to start at the beginning of the buffer and add that text. All right. And if we log that to the screen, we should see that on the screen. All right. We're going to call the write method, and we're going to say write more text. And in this case, we're writing to the middle of the buffer at position 9. So 9 is the index, right? And this is the distance we want to write. So 9 and 9. All right. So different overloads of the write method are available to you. Okay. And then we're going to print our string to the screen, our buffer to the string. And then this is an example of writing to a specific location. So you see that we can write directly to index 18 to change a single byte. And we'll write it again to the screen. So let's take a look at what we get when we do that. All right, so there's our add some text, there's our add some more text, and then there's add some more text, and that's the equivalent of that 43 that we changed into that byte. All right, so you can also read from buffers. All right, so to read from a buffer, you saw that we use the write method primarily here. So the read method is going to allow us to read from a buffer, and there's several other overloads for the buffer that you'll see in your reading for this week in the links that I gave you to see how those methods work and what each method does. All right. Another task that you'll work with when dealing with buffers is to determine the length of the buffer. All right. And to do that, we can't use, like with an array, you'll probably be used to using a length property. All right. We can't use that in a buffer. You need to, because it could be empty spaces. So what we need to use is what's called byte length, and byte length will give us back the length of the bytes that are actually used. All right. Another common thing you'll do is actually copying buffers. So copying one buffer to another buffer, and the buffers actually have a copy method that allows us to do that. And you'll also see an example of slicing a buffer, which allows us to manipulate the slices of a buffer object. So look for those in the code that you'll see in the supplements folder. All right. And that is it for buffers. When we come back, we will talk about streams. Take care.